Okay, this is Unit 2, Lesson 2.1, Part A. We're going to talk about equivalent rational expressions. So we have to first of all recall our exponent laws. So when we deal with exponents, we have specific rules we need to deal with. So an example of our first one, when we've got same base, we're going to add exponents, but we can only do that if it's a multiplying situation. So a multiplying situation here, I've got x as my base, so my x stays my base, and I add exponents. I'm going to get a 5. The second one is a dividing rule. So when we divide same base, we're going to do the exact opposite. So instead of adding them, what's the opposite of adding? Subtracting. So over here, we're going to take 7 and subtract 5, and we're going to get x squared. Up here, we added them. Okay? We're doing opposites. We're going to flip this guy into a positive exponent. If you want to create a positive exponent, whenever they're negative, you need to flip them upside down. Okay? So this guy is negative, so we're going to flip him so he becomes positive. So we're going to have 1 over x cubed. Okay? This guy here, what does that outside 3 mean? It means I have 3 sets of those brackets. So this is the distributive property of exponents. So it's called power of a power. What you're doing is each one of those has a hidden baby 1 on them for an exponent. So the outside exponent here is going to multiply in. So we're going to end up with 2 cubed, x cubed, y cubed. And if it said simplify, we would literally solve the 2 cubed part and get 8. Okay? We have the same type of situation on letter E, only this time they've got different bases in brackets. So different bases in brackets, still same rules. I have 2 sets of these. Each one has a hidden 1 for an exponent, so we're going to multiply the outside exponent in. We're going to get 3 squared y squared, all on top of 2 squared. And again, we would solve the digit part. Okay? So it would be 9y squared over 4. This one we're going to turn into a fraction exponent. How do I change root 6 into a fraction exponent? 6 is my base, but what am I going to do? Good. So the index is a hidden 2. That 6 has a cute little 1 on top of him that we can't see. But what happens is, to get rid of that root sign, the index is going to slide over and create a fraction exponent. Okay, so that's super important. Whenever you get rid of a root sign, it creates a fraction exponent. Okay? Good review from logs. We should have known those from logs. Okay, so we want to know what rational numbers are, rational expressions are. So we're going to be dealing with rational expressions that create equivalents. So, when a numerator and denominator of fractions are integers, so positive or negative numbers, you have a rational number. So anytime you have a fraction, it's considered a rational number. Okay? Now, irrational numbers are the non-perfect square roots, or the run-on decimals, like pi, or base e. They are irrational. Now, here, if I wanted to create an equivalent expression, how can I create an equivalent expression with that number? Negative 2 over 3. How can I do that? Well, there's 2 ways you can do that. One with a picture. So you can draw a diagram. So I could show, all right, we'll forget the negative sign so far. We'll just say I've got 2 out of 3 spots shaded. Okay? That's what we could represent for a diagram. Now, if I wanted to create the equivalent one, what I could do is to each of those sections, I could times it by 2 and make it bigger. So what you could do is you're going to multiply each of them by the same number or the same variable. So if I multiply them both by 2, I'm making an equivalent expression. So that would become negative 4 over 6. Again, it's not reduced. So how can I do it if I have a picture? Well, I cut each section in half. And that shows my 6 parts. And I should have 4 of them shaded. 1, 2, 3, 4. Okay? So that's just equivalent expressions. Now we're talking about, well, what the heck is a rational expression versus a rational number? Rational expressions are where they start putting polynomials into a fraction. So they put x's upstairs and x's on the bottom. So that's basically what a rational expression is. Okay? So each of these are rational expressions. You've got a polynomial on top, a polynomial on the bottom. Same thing here. Polynomial on top and bottom. We have a binomial here and a monomial on the bottom. Whenever things are stuck together, they're a monomial. Over here, a binomial on top and a trinomial on the bottom. Okay? So, we have a couple conditions of rational expressions. We have things that are not considered rational expressions. So it says it cannot contain roots of variables or variables as exponents. Because if we have a variable as an exponent, we're back to unit 1, that's an exponential equation. Okay? We don't want those. So these are the types of examples we're avoiding in this unit. So please write these down. So 2 exponent x plus 3, all on top of 4x minus 2. So up here, what is wrong with this situation? X is your variable. Okay? We're not allowed to have a variable x unless we're in unit 1 with exponential equations. We're not dealing with exponential equations in this unit, we're dealing with rational expressions. That means we have to have polynomials. That's not a polynomial on top. On the bottom it is. But both sections have to work in order for it to be considered a rational expression. So the top here doesn't work, but the bottom does. It doesn't matter. It's still not a rational expression because both have to be. Yes?
This page isn't in your book.
You guys are on that page? Oh, darn. Okay, can you write it on the bottom of page 8, please? Could you write it on the bottom of page 8, conditions of rational expressions? I'll give you a few moments to write that down. Okay, so as we see on the bottom here, we have a radical, and it's got a variable underneath in the radicand. We are not allowed to have that. That is called a radical expression, not a rational expression. So that's what's wrong here. The top is a polynomial, it's fine, but the bottom is wrong. Just like over here, the top was wrong, both parts didn't work, so neither of those are rational expressions, okay? Let's take a look at non-permissible values. So this is back on your page 8, so non-permissible values. So whenever we have a fraction, and whenever we're working with algebraic expressions or fractions, we have to deal with any values on the bottom. Now, if we go to our calculator, we say 6 divided by 0, 10 divided by 0. It's going to say error, can't divide by 0, because you can't divide by nothing. Okay? It's impossible. So your calculator is telling us, hey, yo, dude, you can't do it. It's impossible. So that's why we're trying to avoid answers of 0 in the denominator. Okay? That's what we're trying to avoid. So what we do is we see, well, what would create a 0 on the bottom? And that's what's considered our non-permissible value. So what we do is we try to create each one. We have to factor first, but we try to create and see which one would give us a 0 on the bottom. And that's what x is not allowed to be. So if we look, what cannot be on the bottom? We just discussed it. A over b, that's fraction form. So what is b not allowed to be? 0. So we put 0. B is not allowed to be a 0. So each of these, if I put 3 in for x, so we're going to learn how to store x on our calculator. The instructions are on the next couple pages, but we're going to do it together here. So, it says if we put x equals 3 into each one of these expressions, what would we get? So, we're literally going to do that for each one of them. So let's take our calculator, and what we're going to do is we're going to say 3 store as x. So we have to type it in exactly like that. So we type a 3. The store button is above the on button. So store, and then you hit the x. It's above, or it's right beside the alpha button, I should say. There's your x. Now hit enter. So now your calculator thinks x is 3. Only in this main screen, not the graphing screen. So the main screen, now we're just going to type in x minus 7. So x subtract 7. What are we going to get on top? Negative 4. Now on the bottom, we're going to go x minus 3. Enter. 0. So if x is 3, we get negative 4 over 0. Are we allowed to have that? No. So here, x cannot be equal to 3 in the first one. Because if x equals 3, I end up with a 0 on the bottom. So that means my non-permissible value for the first one is x cannot equal 3. That's my non-permissible for the first one. Okay? Now we're going to stick it into the second one. Okay? So, x subtract 7 is our top number for all of them. So that means we have a negative 4 on top for all of them. We want to know what would our denominator become. So, let's take a look down in our calculator. We're going to type in x squared subtract 9. So, x squared subtract 9. And what do we get? 0. So, if x is a 3 in this case as well, we get a non-permissible value of 3 because we get a 0 on the bottom. We're going to do the same thing with the next equation on the bottom there. We're going to type in x squared minus 4x plus 3. And what do we get? Oh, we got a big bad 0 again. So that means all of these situations give us a 0 on the bottom. So with all of these having a 0 on the bottom, they all have a non-permissible value of 3. Okay? Because if I use 3, as we just saw, we get zeros on our denominators. And that's what we're trying to avoid. So we would say, okay, we figured it out. Now we know that we can't use a 3. That's what that's telling us. All right, what values would be not applicable in the bottom? So what we're trying to do is we would basically make each factor on the bottom equal to 0. So you're taking each factor, make it equal to 0, then solve for x. That becomes your non-permissible. So on the bottom of the first one, I have 2x. I make it equal to 0. Now I solve it. I divide by 2. Is 0 divided by 2? How big is it? It's still 0. So that means if I have a 0, I'll get a 0 on the bottom here. So that means x cannot be 0 for the first one. X cannot be a 0. When it's a binomial, it's pretty easy to see what number would create a 0. So what creates a 0 in the second one? What subtracts 7 gives me 0? 7, it's the opposite sign. So here, x cannot be equal to 7. So if I put a 7 on the bottom, I get a 0. Okay, we don't want that. Over on the next one, we have to make each bracket equal to 0 and then solve for x. So let's take a look at the first bracket. What would make that bracket equal to 0? Positive 3. 3 subtract 3 gives me 0. So that means x cannot be positive 3, because I don't want it to be a 0. We're trying to avoid that. Now, since here I've got a number in front of x, I'm going to show you the longhand way to solve it, and then I'll show you the shortcut. So, the longhand way to solve it is this. You take the actual factor and make it equal to 0, and you solve for x. So I'm going to move the 1 to the right-hand side, so I'm going to add 1 to both sides. So I'm going to get 2x equals 1. Now we're going to divide by what's in front of x. Divide by your coefficient of 2, so we get x equals 1/2. So if x is equal to 1/2, I get a 0 on the bottom. Yes? You are right. My goodness. So it's the opposite. Thank you. I wrote the opposite one down. I think I was thinking too quickly. All it does is change the sign. Thanks for catching that, guys. So we're going to subtract 1 instead of add 1. All this does is it makes our number 1 a negative. Okay? Now, what are you noticing? What is the opposite sign of positive 1 here in the bracket? What's the opposite sign of positive 1? Negative 1. So, there's a rule here. The quick trick rule is this. Just like we would take this guy out of brackets, what is the opposite of positive or negative 3? It's a positive 3. What is the opposite of 1? Negative 1. but the number in front of x is going to slide under and create a fraction answer. So here we see the end of the fraction answer. Well, where did that 2 originally come from? It was sitting in front of x. So, for example, if I've got something that looks like this, 7x plus 4 in brackets, and I say, what would be its non-permissible? We always take this digit opposite sign. Okay, -4. Now, if you look in front of x, if there's a digit, slide it under. So these are going to become a fraction. Okay? If there's a hidden 1 in front of x, we don't have to worry about that. It's just a digit, opposite sign. So if it was x plus 5 in brackets, only a hidden 1 in front of x, those are easy ones. You just do opposite sign, -5. -5 plus 5 give me 0. But the minute you stick something in front of x, you have to create a fraction. Okay? Just like this guy. Alright? So we're going to create a rule. We're going to write the rule down. So I'm just going to erase all this because I have it underneath all this. So the rule is this. Okay. So here's our rule, and this is what I'd like you to write down, please. Okay. All of that enclosed in yellow. I'd like you to write it down, please. I'll give you a few moments to small it down, play with your writing. Okay, so now we're going to take a look at rational expressions. So this one here, this is also showing us another example. X equals 3 is a non-permissible value, okay? So,
We don't have that one either.
you don't have this one either?
No.
You have this stuff?
Yeah.
Okay, good. This, I think the reason you don't have this is because it's just from that other page. It's like basically telling us the answer, which we already knew. We knew that x plus 3 was non-permissible, okay? What about these ones? Let's take a look. X is on the bottom here, all by itself. What would the non-permissible be? Just 0. Yeah. Okay? So here it's just 0. Does this guy here, 10x, have a denominator at all? It's got an invisible 1 for a denominator, but does it have a variable on the bottom? No. So how do we say no restrictions? XER. Good. What about x plus 3? Any restrictions there? Nope. No restrictions. XER. This guy, 5 divided by x, does he have a restriction? Yep. X can't be what? Good. X cannot equal 0 here. So that's his non-permissible. Because remember, you can't divide by 0. It's impossible. All right, what about this next couple? Let's take a look here. All right. 4a over 3bc. So whenever you've got a whole bunch of variables stacked side by side, that's basically just 0. Because if I make one of them 0, the whole bottom becomes 0. Because they're all side by side multiplied. So that means B and C cannot equal 0. That's our not permissible. The next two sections have brackets. If there's brackets, again, what makes each bracket become a 0? So, what makes the first bracket become a 0? What plus 2 gives me 0? -2. So we say x cannot be -2. What else can x not be? What in this bracket would make it 0? What subtract 3 gives me 0? +3. Okay, 3 subtract 3. Remember, if it's in brackets, you're just doing the opposite sign of the guy without the variable. So 7, what's his opposite sign? -7. So x cannot be -7. What's the opposite sign of -3? +3. So x cannot be +3. I guess you don't have to put the plus sign in front. When we've got other situations like the ones you see below, they have to be factored first. Okay? So we're going to take a look at these guys and we're going to factor them. So x squared plus 1. What do we know about something with two perfect squares? Is that a difference of squares? What does the word difference signify? Subtraction. Do I see a subtract sign in the middle? No, so it's not a difference of squares. So because this guy's not a difference of squares, we can't factor him. So if I made x become a 0, okay, this guy's non-factorable. But if I made x become a 0 here, that would still just be 0 plus 1. We don't end up with an answer of 0 on the bottom. That means x has no boundaries for that one. Okay, it's got no restrictions for that one. It's XCR. And it's because he's attached with a plus 1. Okay? Let's see this one. We have to factor that guy. We're going to diamond a -6 with a -1. Well, that's going to give us -3, +2. So that's what's going to go in our brackets. So I would open 2 brackets. And I'm going to have x minus 3 and x plus 2. So what would make each of those brackets equal to 0? What could I put in the first one to make 0?
3.
What's the opposite of -3? +3. So we say x can't be that. X can't be +3. What makes this bracket equal to 0? What's the opposite of +2? -2. So x also can't be -2. So we can't be -2 or +3 in that case. Okay? The next one, if I do the diamond on him, I'm going to get 2 brackets that are identical, actually. Yep. Yep. So we're going to get x minus 4 and x minus 4. So when the brackets are identical, you only have one non-permissible. So what makes those brackets equal to 0? +4. It's always the opposite of the sign in the brackets. So for this one right here, x cannot equal +4. That's its non-permissible value. Now, how is this last example different from the first example? There's a minus in the middle. So if I've got a minus in the middle, I instantly check, are they perfect squares? Yep, they are. So that means I can square root them and open 2 brackets. So x starts the brackets. I have a 3 at the end of each bracket. And I separate with what? Plus, minus. So whenever you get them that they're opposite, you can say it this way. X is not allowed to be plus and minus 3. Okay, so x cannot be plus and minus 3. You don't have to state them separately like over here. You can just state them plus and minus like that. Okay? All right, we're almost done this lesson. The first part. Okay, equivalency. So equivalency basically just means that we are going to be creating a fraction that'll give me the same decimal answer in the end. So what that means is we're going to write numbers that multiply or divide to both the top and bottom. Because whenever you do to one of them, you got to do to the other. You got to do it to the top and the bottom both. You can't just do it to one of them. So if I wanted to create an equivalent expression to 8 over 12, I could do one of 2 things. I could multiply both expressions by a number or a variable, or I could divide them both by something. I could simplify them lower. So both of those I know divide by 4. So I could divide both of them by 4 and create a smaller one and get 2 over 3. I could also multiply top and bottom both by the letter w. And then we could get 8w over 12w. As long as I do it to the top and the bottom, it's an equivalent expression. Okay. 3 over 12, same thing. They're showing you exactly different expressions. We can express it in many different ways. Divide by 3 is what they've done. Divide by 3, and we get 1 over 4. Then what they do to 1 over 4? They started multiplying top and bottom by each digit. So they multiplied them each by 5. Then over here they multiplied them each by 6. Then over here they multiplied them each by, I'm not sure. It's something. It must be a fraction or a decimal.
3 points.
All right. Now, how do we know that everything is equivalent if it's just a fraction with no variables? Because we get the same decimal answer. Okay? That's why. So you get the same decimal answer. Now, what if it's an expression? How can you tell if they're equivalent? they all simplify to the same reduced one. Okay, so they all simplify to reduced form. They all reduce form. Okay, they all simplify to the reduced form. So, we have a different expression up here. We've got one with 4x squared plus 8x with a 4x on the bottom. So, we want to make an equivalent expression to that. Who has an idea of what we could do to make an equivalent expression to that one? What could I do? Divide them all by 2? Sure. Okay, so the first one, I'm just going to put it over here. We're going to divide it all by 2. Okay, so if I divide it all by 2, I'm going to end up with 2x squared plus 4x all over 2x. Okay, what else could I have done? I could multiply everything by 4. So I could put the top in brackets and multiply it by any number up front. I would do the same thing to the bottom. Multiply it by whatever number I want. I could also reduce it even further. I could have started and reduced them all by 4 because they all divide out by 4 and they all have an x. So I could have completely reduced it so there's no more bottom denominator. So there's multiple different ways you can do these. Okay? Now, if it's a multiple choice question, you have to go through each of those answers to see which one is a possible solution. Because they may have done something completely different. Maybe they multiplied everything by 2w. Or maybe they divided everything by a 9. They got fractions. So you have to see if they all work. Okay? We have the next one here. So we're comparing these two fractions right here, these two expressions. Okay, top of the next page. We're comparing these two fractions. Well, how can I tell if the big fraction, the big expression is equal to the smaller one? Well, what I do is I start reducing. So that's what we've done. We've taken our original and we've started reducing it. So what they did was they just reversed the bottom so that they had the x first. So they had, here we have a 2 subtract the 6x. They just swapped them places. Okay? Then what they did, what do you notice they did? What did they do between this step and this step? What do you notice is missing? The negative side. So they divided out a negative of things. So everything that was negative goes positive. And then everything here, the 2 that was positive now goes negative. So here they have divided out a negative 1. All right, what have they done at the next stage? What have they done to the bottom? The top has stayed the same, but what have they done to the bottom? Okay, what do we call that? They factored out a GCF. So here we've got GCF factoring. Okay? And the minute you get a GCF factoring, you can now reduce the top numbers. 18 divides by 2 beautifully, and that's how we get our 9 on top. Okay? So, step by step, we want to see if they can rearrange to look the same. So, over here in the first one, they had x sitting first and then the constant. That's why they had to reverse the bottom. They had to put the x first, then the constant. Okay? Alright, we're going to check these two now. Let's check those two and do the steps together. So, which one looks like it can be reduced? The first one or the second one? The first one. So, what could I divide out of the first one so that I could reduce it? 2. Good. Now, do you notice anything that is sitting backwards or written backwards comparatively? Right, on the top, it's written backwards. So, since this guy's written backwards and this guy here has the x first, we're going to swap those two places first. So we're going to have negative 2x plus 2 all over 4x. Now we're going to divide out 2 to everything. We're going to see if we end up with that same last expression right here. So we're dividing everything by 2. Now, what do you notice the x is? The x positive or negative? The x is positive in the blue one I have circled here, the one that we're comparing to. So if x is positive, how do I create a positive x on the top there? What would I have to factor out to make this guy become a positive x? Right, you're going to have to factor out a -2. So I'm going to factor out -2, and I'm going to get x minus 1. Okay, all over 4x. Now, let's take a look. This is the section where we can do math frac. Whenever you've got something outside brackets, you can math frac it with the bottom if there's something outside brackets or no brackets. So we've got no brackets on the bottom. That means my -2 and my 4 can math frac. We're going to divide them both by 2. But when I do that, does that get rid of my negative? No, it doesn't. So I'm going to reduce everything by 2 right now. That's going to give me a negative hidden 1 in front of my x minus 1. And on the bottom, I'll end up with a 2x. Stop working on x minus 1 and 2x bottom. So, did I end up with an answer that looks like we're comparing to? It's really close, but is it identical in every way? No. They are not equivalent expressions. So the first one we worked with, yes, these guys were equivalent. It worked out, and when we simplified it completely, everything worked out so they matched identically. Here we simplify, and we have one thing wrong. We still have a negative out front. So that means their final simplified answers don't match. It also means you can check your work. One of the ways you can do it is this. And this is something we could have done from the very start. Is you could pick any number for x. Maybe a 5, maybe a 2, maybe a 1, whatever you want for x. Choose a number value. Substitute it into this equation, substitute it into this equation. See if you get the same answer. If you get the same answer, you're good to go. If you don't, then they're not equivalent. Okay? So this guy, because of this, these are not equivalent. Okay? They are not equivalent expressions. Okay? We're going to look at 2 more. Bottom of your page. So, try those 2. I would like you to find an equivalent expression for each of those. I want you to find an equivalent expression for each of those. You guys don't have those either? Really? Oh boy. Okay. Well then, let's just do them together right now. Okay. So, if I want to, just watch it here, please. The opposite side of notes, I'm usually the opposite. Okay, let's take a look, guys. Guys up here, please. So, when we take a look at these expressions, we're actually just taking a look at what can we reduce. If we have something identical on top and bottom, we can reduce it 100%, which means it can disappear. So, do I have something on top and bottom that can disappear on the first one? Yeah. You have x plus 2 and x plus 2. If they're identical brackets, top and bottom, you can reduce them. So these 2 would be gone. So that would give you 3 over x minus 4. That's an equivalent expression. If I wanted to do another equivalent expression, I could have left those brackets there, and I could have times everything by the letter w. I could have put a w there and a w there. That's an equivalent expression. Okay? The bottom one, same thing. I could times everything by q. I could divide out a common expression. I could divide out the x minus 1s. Okay? So there's multiple ways to make equivalent expressions. This concludes lesson 2.1, part A on equivalent expressions.